Graph the exponential function based on its transformation from its parent function and identify its domain and range. So this is very typical of what you're going to see in the test. You're going to see a space to put the parent function, a table to put your final answer, 5 points, graph, and domain and range spaces. Now notice your graph is not a simple 10 by 10 by 10 by 10. Instead, it goes down to 6 and up to 13. Now, a hint is that your graph should probably fit the graph that we give you. Otherwise, we wouldn't give you such an odd graph. So the first thing we need to recall is the parent function. See if you can write the equation at the top of your page. I'll pause and you should do the same. As I've written it, there's a black section, which is your parent function, a red section, which is transformations of x, and a blue section, which is a transformation of y's. So if we can identify what is your parent function here, well, it's going to be y equals some base raised x. In this case, the base is 2. So I'm going to use x, and then y equals 2x raised x. Now remember, you always use the same x's. Can you recall what they are? -2, -1, 0, 1, and 2. And your y's, you get the y's by plugging it in. I always start at 0, move to the positives, and then backtrack to the negatives. Just my flow. So anything raised 0 is 1, anything raised 1 is itself, so 2 to the 1 is 2. All right, I get 2 raised 2, so 2 squared is 4. 2 raised to a -1, well, negative exponent means flip it, 1 over 2 to the positive 1. And this is 1 over 2 to the positive 2, which is 1 over 4. So once we have our parent function, we then need to look to see what are our transformations. Well, so far, all we've done has been the 2 and the x. Everything else, that 3 in front, that 4 up top, and that 6 out back, all need to show up in my transformation table. So in red, I'm going to look to my formula. I'm going to see what is happening to my x's. Well, this is minus h, so this 4 is happening. So there's a 4 going on to my x's. And you need to remember that it's always going to be the opposite. So if this says -4, you're going to say x plus 4 because this is really shifting 4 to the right. And then in blue, I'm going to put everything else. So I can kind of like check that off. And then in blue, I'm going to put everything else. In front of the parent function is a 3. After the parent function is a -6. So I'm going to do to all my x's, and I'm going to add 4. -2 plus 4, -1 plus 4, and so on. So all of these are going to get +4s, and I'm going to result with all my x's. I'll pause and see what you get. 2, 3, 4, 5, 6. Now a good check, if you did this correctly, is that if I plug in the middle number, my exponent turns to a 0. Does that happen? If I put in a 4, 4 minus 4 is 0. So that's a quick little check to make sure I did it correctly. And we're going to do the same thing for the y's. So I'm going to take all of these y's, plug it into this transformation rule, and I'm going to get a variety of y's, 5 different y's. Now I'm going to start with the bigger ones. I'm going to avoid the fractions and leave those till last. So in this case, I'm going to start at the bottom of my table, and I'm going to do 4. This is what my table looks like before I start calculating, and this is what it looks like after. What I'm going to do now is draw my asymptote. My asymptote is this number right here, -6. And then I'm going to plot all my points. Those are my points, my asymptote. Draw a nice curve through them, and you're almost done. Now my range has to do with the y and the asymptote. The asymptote is -6, and it's all above, so it's greater than. And my range domain